Hello everyone, I'm Dr. Khallouk Khadija from the Faculty of Science Dar al-Mehraz, Fez. My presentation will about catalytic conversion of carbohydrates by mixed zinc vanadium oxides obtained via mechanochemical synthesis. To introduce my work, I'm going to talk about biomass as an alternative resource to substitute petrochemical products. So, the declining reserves and fluctuating prices of fossil fuels necessitate a switch from conventional to renewable power source. The transformation of renewable biomass resources into valuable chemicals has received a great attention due to their abundance and is a promising sustainable alternative for the production of important intermediates as low cost. One of the main components of the biomass, carbohydrates, can be obtained from hydrolysis of biopolymers such as cellulose and hemicellulose. Catalysis also is recognized as a key ingredient in the development of sustainable, efficient, and economical routes for the transformation of biomass constituents to value-added products. In this work, we use mixed zinc vanadium oxides to convert carbohydrates into organic acid. Let's start with the synthesis catalyst. The catalyst was synthesized via simple mechanochemical route based on milling of stoichiometric quantities of zinc and vanadium oxide in vibro ball milling for 8 hours. The obtained mixture was calcined at 400 degrees Celsius for 4 hours, then characterized. The results of Xray diffraction show the obtention of one phase. The Xray diffraction pattern revealed the absence of impurities and the high crystalline nature of the synthesized mixed zinc vanadium oxide material. For SEM image, it shows the good dispersion of material as we see in these pictures. Particle size varied from 80 to 120 nanometer. The composition of obtained material is analyzed with X-ray photoelectron spectroscopy. The results show the presence of only zinc, vanadium, and oxygen. For the spectrum of Z entropy, we see two bending energy peaks at 1021.5 and 1044.6 electrovolt that it could be attributed to zinc 2+. The bending energy peaks located at approximately 525.9 and 580.2 electrovolt for the spectrum of vanadium 2p are characteristic of the presence of vanadium 5+ ions. In addition, the high-resolution oxygen 1s spectrum could be resolved into three components at 530.8, 531.7, and 533.3 electrovolt. The first and second peaks can be assigned to the latest oxygen, since oxygen has two different located environments, oxygen zinc and oxygen vanadium. The peak at 533.3 electrovolt was due to the adsorbed oxygen. However, it is highly probable that there is an electronic dynamic exchange between zinc and vanadium, which underlies the exceptional catalytic performance of zinc vanadium oxide that we can see it in the results of catalytic oxidation. So the obtained mixed zinc vanadium oxide is used in carbohydrate oxidation, where the reaction consists on the kinetic reaction using 100 mg of carbohydrate, glucose, xylose, galactose, and arabinose, mixture with 10 mg of catalyst at 150 degrees Celsius. The kinetic is from 5 to 60 minutes, and the solvent used is water and H2O2. After a reaction, the product is centrifuged, then analyzed with a higher performance liquid chromatography, then the catalyst is regenerated. The result of carbohydrate conversion in water using mixed zinc vanadium oxide catalyst show a good conversion, which exceeds the 70% for the for carbohydrates used after 60 minutes of reaction. The presence of hydrogen peroxide improves the conversion of carbohydrate, which has exceeded 80%. The oxidation of carbohydrate with the mixed zinc vanadium oxide catalyst was selective to very important organic acid. Glucuronic acid for galactose, galacturonic acid for glucose, glycolic acid for xylose, and arabionic acid for arabinose. Also, we can see that the use of hydrogen peroxide improves also the selectivity of organic acid, which reached more than 50% for the 4 carbohydrates used. In conclusion, we can say that mixed zinc vanadium oxide was synthesized via simple mechanochemical route. The carbohydrate was converted into organic acid at 150 degrees Celsius after 60 minutes. We have a good selectivity to important organic acid. For xylose, we obtained glycolic acid, glucose, galacturonic acid. For galactose, we obtained glucuronic acid, and for arabinose, we obtained arabionic acid. Also, we have seen that the addition of hydrogen peroxide enhanced the conversion of carbohydrates and the selectivity to organic acid.